Hello, Algebra students. Let's look at some of the most challenging examples of solving multi-step equations that you might see on the GED math test. So directions say a student solved an equation as follows. What error did the student make? And what you're going to see here is you're going to see each equivalent equation written out. But what they don't show me is their balance change, what's going on from line to line, or what they simplified, what they did. And so we're going to need to kind of puzzle that out. So let's take a look here. I see the first equation says 2 times the quantity of 11 minus x equals 4 times the quantity of x minus 9. And that's a little ugly there with those x's both trapped in groupings. And so the very first thing I would want to do is do that distribution, that multiplication that I see here when I have these numbers shoved up against these groupings. So let's go ahead and do that. And we can see that's what they did first as well, because 2 times 11 is 22. And 2 times negative x is negative 2x. So nice. I like that first step they did on the left-hand side. Now, examining the right-hand side of the equation, the same thing there. I see an expression I can simplify. That 4 is shoved up against the parentheses, so I can do that multiplication. 4 times x is indeed 4x, and 4 times negative 9 is indeed negative 36. Love their first step. I do not believe they made a sign error when distributing. Let's look at the next step. Now, this is a little tricky because they might not do it the way you do it. So I want you to examine both of these lines and see the difference between the two so we can try to see what happened in between. All right. So we can see that originally we have a constant term, a plain old number term, and a variable term, in this case next term, on the left-hand side. And we also see that on the right-hand side. There's a variable term and a constant term. But now look at the line below that. In the line below that, we just have a constant on one side, constant term, and a variable term on the other side. So it looks like they moved them both at the same time. And we are going to want to do the same thing. And we're going to want to move in the same direction as they did if we're going to make sure that they didn't make an error. So looks like they moved the x's over to the right-hand side. So I will do that. I will take the x term that's on the left-hand side and I will move it using the opposite operation. So I would be adding 2x to that left-hand side in order to cancel out the negative 2x. Now I can do whatever I want as long as I do it to both sides. Now, they didn't only move the x's, they also moved the constants over to the other side, the left-hand side, so I will do that. I will take this constant, this minus 36, on the right-hand side, and I will move it over to the left-hand side. And I'm going to do it at the same time. It's okay, guys, it's okay. Breathe through it, breathe through it. Let's see what would happen if we do this. So subtracting 2x and adding 2x would cancel on that left-hand side. That'd be great. And 22 plus 36 is 58. So that's awesome. I like that side. Now on the right-hand side, subtracting 36 and adding 36 would cancel, but we found the problem. 2x plus 4x is not 2x. It's 6x. There's our issue, but why in the world did they make that issue? So let's go ahead and let's look at B, C, and D here. So it says they did not use inverses to cancel the variable term on the left-hand side. Let's go ahead and see if that's the issue. So I think, here, let me just clear this out, you guys. All right, so did not use inverses to cancel the variable term on the left-hand side. So there's the left-hand side. There's the variable term. They should have used inverses like we did. We said, oh, that term is subtracting. We should add. It looks like they did the really common error of using the signs that they saw, even though these x terms are on either side of an equal sign. Instead of doing plus 2x, it looks like they did 4x minus 2x. They didn't use the inverses. So why is it so important to pay attention to what side of the equal sign you're on? Well, because when you're on the same side, you obey symbols. But when you're on the opposite side and we want to move from across an equal sign, that's when we use inverses or opposites. So this B was that student's problem. Wonderful. All right, you guys, I recognize that that's tricky. That's one of the reasons I said this is among the trickiest problems on the GED. But, you know, I think that my advanced level students, you're ready to attempt this kind of stuff. You've got this. You've got so many skills in your belt. You can look at what they did, even if it wasn't the way that you would have done it, and try to figure out if they did something true or not. All right, you guys, super proud of you. Happy learning.